Hello, everybody. So we're going to continue with Module 12, Lesson 3, Writing Equations from Tables. We're on page 347 of the 6th grade Go Math textbook for middle school. And so our essential question you need to be able to explain at the end of the lesson is how can you use an equation to show a relationship between two variables? Right, so writing an equation to represent a real-world relationship. The table shows how much Armand earns for walking 1, 2, or 3 dogs. Use the table to determine how much Armand earns per dog. Then write an equation that models the relationship between the number of dogs walked and earnings. Use your equation to complete the table. So part A, for each column, compare the number of dogs walked and earnings. What is the pattern? Well, I see the number of dogs walked for 1 is 8. Then 2, $16, 3, $24. Well, we know for it to be an equation that these have to have a consistent pattern. Well, the only way to go from 1 to 8 is either add 7 or multiply by 8. So if it's add 7, that should be true of all of them. Well, 2 plus 7 is not 16, so it's not add 7. Let's see if it's multiplied by 8. 1 times 8 is 8. 2 times 8 is 16. 3 times 8 is 24. Yes. So earnings is always 8 times the number of dogs walked. So based on the pattern, Alman earns how much per dog? $8. What's the equation that relates the number of dogs Armand walks to the amount he earns? Let E represent earnings and D represent dogs. So E, earnings, is equal to 8 times the number of dogs. And we could also write this as E equals 8 times D, or E equals 8 times D. All three of them basically mean the same thing, right? All right, so D, use your equation to complete the table for 5, 10, and 20 dogs. So 5, 8 times 5, $40. 10 times 8, $80. 20 times 8, $160. So Armand's earnings depend on the number of dogs walked. What if Armand changed the amount earned per dog to $11, what equation could you write to model the relationship between the number of dogs walked and earnings? Well, there's no real difference between the equations except you're increasing the 8 to 11. So we could write 11 times D, or 11 using the multiplication symbol, or put the variable right next to the coefficient. All right, so any of those three ways is a correct method. All right, page 348. Write an equation based on a table. That's kind of what we just did, right? So the relationship between two variables, where one variable depends on the other, can be represented in a table or by an equation. An equation expresses the dependent variable in terms of the independent variable. Now you might say, well, what's the difference between using a table and an equation? Well, an equation, I can solve any independent variable, whereas a table only gives us a few possibilities for the independent variable. So That's only real difference is that the table is more limiting than the equation. So when there is no real world situation to consider, we usually say x is the independent variable and y is the dependent variable. The value of y depends on the value of x. So when we look here at a, we see that x is 1 and y is 5/10 or half. We see that when x is 2, y is 1. When x is 3, y is 1.5. When x is 4, y is 2. And finally, when x is 5, y is 2.5. So what's the pattern that we notice? Well, we notice that y is less than x. So it could be minusing, right? Well, how do I go from 1 to half? That would be subtract a half. Well, what's 2 take away half? Well, that's 1.5. So it's not subtracting. So it must be dividing. So 1 divided by 2, that's a half. What's 2 divided by 2? 1. What's 3 divided by 2? 1.5. Okay, so it's dividing by 2. So we can say each y value is 1/2 or 5/10 times the x value. And so we could write that as y equals 1/2 whatever x is. Or we can use a decimal. All right, how about b? So here we see that x is 2 and y becomes 5. When x is 4, y is 7. When x is 6, y is 9. When x is 8, y is 11. And when x is 10, y is 13. So here I see that there's a difference of plus 3 in each one. 2 plus 3 is 5. 4 plus 3 is 7. 6 plus 3 is 9, so on. And this one was times 1/2, right? All right, so here, compare the x and y values to find a pattern. We notice that from x to y, it's adding 3. And it says each y value is 3 more than the corresponding x value. So the equation would be y, which is dependent on the x value. Y is equal to whatever x is plus 3. All right, so now let's see if we can come up with our own equations. And we're going to write y in terms of x. That's what these two equations have been. Y is equal to x, whatever 3 is. X plus 3. So here we're going to say y is equal to something. Well, first we have to compare x's and y's. So here we see a difference of 2. 11 minus 2 is 9. 10 minus 2 is 8. So we see that they're decreasing by 2. So y the value of y is whatever x is minus 2. All right, how about 3? 10 to 25, 12 to 30, and 14 to 35. So it's increasing, right? Let's see. If it was, I can add 15 to 10. That would give me 25. But 15 plus 12, that's not 27. That's not 30 if I add 15. So it's got to be multiplying by something. 2 times 10, that's 20. 3 times 10, that's 30. Oh, so it's in between, right? So 10 times 2.5. So these are 2.5 times the y. The y is 2.5 times whatever x is. So we can say 2.5 times x. 4. Well, to go from 5 to 10, I either multiply by 2 or add 5. So 5 times 2 is 10. 4 times 2 is 8. Okay, so it's not multiplied by 2. Let's try 5. Plus 5 is 10. Plus 5 is 9. Plus 5 is 8. Yes. So we're adding 5 to the x. So y equals whatever x is plus 5. And finally, number 5. Here, whenever x is 0, y is 0. Well, that could be adding 0, subtracting 0, or multiplying by 0. So that's not really going to help me any. I don't know that. So let's look at 1 and 2. Well, I can multiply by 2 or add 1. But if I add 1 to 2, that's 3. So it's not adding 1. Subtracting 1, no, that wouldn't make any sense because 2 is larger. So it must be multiplying by 2. 1 times 2 is 2. 2 times 2 is 4. Yes, so y is equal to 2 times x. All right, let's look at let's look at the next section. Using tables and equations to solve problems. Page 349. You can use tables and equations to solve real-world problems. So example 2. A certain percent of the sale price of paintings at a gallery will be donated to charity. The donation will be $50 if a painting sells for $200. The donation will be $75 if it sells for $300. Find the amount of the donation if a painting sells for $1,200. So let's look at the information, analyze the information. We know that the donation amount when the sale price of a painting is $200 and $300. Right? They gave us that information. We need to find the donation amount if the painting sells for $1,200. So what could our plan be? Well, we can make a table to help determine the relationship between sale price and donation. And then we can write an equation that models the relationship. And then we can use the equation to find the unknown donation amount. So here's our table. We have a sales price of $200 and $300. When I sold it for $200, the donation amount was $50. When it sold for $300, it was $75. So we can use the idea of percent for this one, right? So how can we turn 50 over 200 into hundredths? Well, I can divide 200 by 2, right? If I divide 200 by 2, I also have to do the same thing to the numerator. So 50 divided by 2 is 25. Well, 25 hundredths is 25%. Let's see if that's true of this one. If we have 75 over 300, let's divide 300 by 3 to turn it into 100. And 75 divided by 3 is 25. 75 is just 3 quarters, right? 3 quarters divided by 3 is 1 quarter. So 25%. So it's basically the sales price times 25%. So the equation would be the donation amount equals 25 hundredths of the price, or 1/4 of the price. So if we plug in 1,200 for the price and we multiply by 25 hundredths, we get $300. So the donation to charity would be $300 in that case. And then we would justify and evaluate it. So substitute the values from the tables for P and D to check that they are solutions of the equation. So in our first one, we said 200 times 25 hundredths. That would be 50. 25 hundredths times 300. That's 75. 3 times 25. And we just did 1,200. 1,200 times 25 hundredths is 300. All right, so let's do some practicing then on page 350. When Ryan is 10, his brother Kyle is 15. When Ryan is 16, Kyle will be 21. When Ryan is 21, Kyle will be 26. So write and solve an equation to find Kyle's age when Ryan is 52 and tell what the variables represent. Well, let's write the names. So we have Ryan and we have Kyle. It doesn't tell us what variables to use, but I'm going to use R for Ryan and K for Kyle. All right, so when Ryan is 10, his brother is 15. When Ryan is 16, his brother is 21. When Ryan is 21, Kyle is 26. Well, so what's the relationship between this? Well, if I add 5 to 10, I get 15. If I add 5 to 16, I get 21. If I add 5 to 21, I get 26. So the relationship is add 5. All right, so what's the equation I can use? Well, Kyle equals 5 plus Ryan's age. So K equals Kyle's age, and R equals Ryan's age. So when Ryan is 52, how old is Kyle? Substitute 52 for R, and 52 and 5 is 57. So Kyle is 57 years old. All right, so now let's practice and write our equations in terms of x, y in terms of x. So I see that from x to y it's getting smaller, y to x getting smaller, so this decreasing. So we can divide or subtract. If I subtract 4 from 10, that does give me 6. If I subtract 4 from 20, that does give me 16. If I subtract 4 from 30, that is 26. All right, so the relationship is minus 4. So y equals what? Y equals whatever x is minus 4. Okay, number 2. 0, 0, that's not going to help us any. 1 to 4, I could add 3, but 2 plus 3 is not 8. So it's not adding 3. My only other choice, since it's getting bigger, is to multiply. And 1 times 4 is 4, 2 times 4 is 8, and 3 times 4 is 12. So we're multiplying by 4. So I can tell you y's value if I multiply whatever you tell me x is by 4. Let's see if that's true. 4 times 1, yep, 4. 4 times 2 is 8. 4 times 3 is 12. All right, how about 3? From 4 to 7, that's adding 3. 6 plus 3 is 9. 8 plus 3 is 11. Yes, so we're adding 3. So y equals x plus 3. So y is always 3 more than whatever x is. And 4. 12 divided by 6 is 2. 24 divided by 6 is 4. 36 divided by 6 is 6. Okay, so we're dividing by 6. Or we could say 1/6 times x. So y equals x divided by 6. All right, number 5. Jameson downloaded 1 digital song for $1.35, 2 digital songs for $2.70, and 5 digital songs for $5.75. Write and solve an equation to find the cost to download 25 digital songs. All right, so 2, they told us, was $2.70. 5 songs was $6.75. Well, so what's 10 times $1.35? Well, technically, when I'm multiplying by 10, I can just move the decimal point one place to the right. So it should be 13.50. 10 times 1 is 10. 10 times 35 cents is $3.50, so $13.50. All right, so the number of songs is N and the cost is C. So what is the relationship here? So C, the cost in amounts, or in dollars, equals $1.35. Each song costs $1.35 times the number of downloads. So what's 25 songs? Well, we can take 135 and multiply by 25. So we get $33.75 would be the cost of 25 songs. So 6. This is basically the essential question, right? Explain how to use a table to write an equation that represents the relationship in the table. So basically our first step is to compare the x and y, or the two values in the chart, right? So first we're going to compare the x and y values. Why are we doing that? Because we need to find a pattern. Okay, remember, it needs to be consistent for all pairs of x's and y's. And then we're going to use that pattern to write the equation. Where we express y in terms of x. So let's see if that makes sense. So compare x and y. So in this table, we're multiplying the number of songs by $1.35. So we know that that's the relationship. So if it's times 35, the y, or in this case c, the dependent variable, is $1.35 times the number of songs. Or in our terms of x, this would be the x, the independent variable. Right, so let's look at number 7. What does it mean for an equation to express y in terms of x? Okay, well, the variable y is on one side. Okay. And the expression on the other side shows the relationship between y and x. Okay, for example, if we looked at y equals x plus 3. Okay, well, we have y on one side of the equation, and on the other side, we see the relationship between x and y. The value of y will be 3 more than whatever x is. So that's all that means. Okay. Number 8, the length of a rectangle is 2 inches more than twice its width. Write an equation relating the length of the rectangle to its width. Right, so what's the length? Length is equal to 2 times its width plus 2. 2 inches more than twice its width. All right, let's look for patterns here. Compare the y values in the table to the corresponding x values. What pattern do you see? How is this pattern used to write an equation that represents the relationship between the x and y values? Well, they're getting smaller from x to y. So if I subtract 15 from 20, That would give me 5. But 24 minus 15, that's 9. So it's not subtracting 5. It's not subtracting 15. So let's try divide. 20 divided by 4 is 5. 24 divided by 4 is 6. 28 divided by 4 is 7. So divide by 4. Or we could say 1/4 of it. So y is 1/4 the value of x. Then write an equation to 1/4 of x. 1/4 of 20, 5. 1/4 of 24, 6. 1/4 of 28, 7. All right, number 10. A student modeled the relationship in the table with the equation x equals 4y. Explain the student's error and write an equation that correctly models the relationship. So this is saying that if you tell me the value of y, it can give me x. Well, if y is 8, 8 times 4 is 32. That can't be right. Isn't it 4 times x? Let's see, 4 times 2 is 8, 4 times 4 is 16, 4 times 6 is 24. Yeah, so this is times 4. So the student got them backwards, right? The variables are switched. It should be 4 times x equals y. All right, number 11, A. Marvin earns $8.25 per hour at his summer job. He wants to buy a video game system that costs $206.25. A. Write an equation to model the relationship between the number of hours worked, H, and the amount earned. All right. So the amount earned is what? $8.25 times the number of hours he works. So now let's solve it to find out the number of hours he has to work. So he has to earn $206.25 at $8.25 per hour. So we see that the variable is being multiplied by $8.25. So we're going to divide both of those by $8.25. That's going to isolate the H. All right, so what is $206.25 divided by $8.25? Well, let's multiply both of them by 100. Okay. So 2,062 divided by 825. Well, I know it can't be 3 because 3 times 800 is 2,400. So I'm going to try 2. 2 times 5 is 10. Here, let's do it up here. 2 times 5 is 10. Regroup to 1, 10, 5, 1650. All right, so we have a remainder of 412, which cannot be shared with 825. Let's bring down the 5. 8 times what? If I had 800, how many 800s would be in 4,000? Be about 5. So let's try 5. So 825 times 5. 4125. All right, so 25 hours. Marvin needs to work 25 hours to have enough money. All right, 352. Number 12. For every hour that Noah studies, his test score goes up 3 points. Explain which is the independent variable and which is the dependent variable. Write an equation modeling the relationship between hours studied and the increase in Noah's test scores. All right, well, the hours of studying is independent. So dependent would be test score. So what would the equation be? Test score S, his test score is equal to 3 times the number of hours practiced. If he practices 1 hour, his test score will go up 3 points. If he practices 2 hours, his test score will go up 6 points, and so on. All right, 13. Make a conjecture. Remember, that's like a guess, right? A conclusion. Compare the y values in the table to the corresponding x values. If possible, write an equation modeling the relationship. If not, explain why. Okay, so to go from 1 to 3, I can add 2 or multiply 3. 1 plus 2 is 3. 3 plus 2 is 5. Okay, so it's not adding 2. Let's multiply by 3. 1 times 3 is 3. 3 times 3 is not 6. So there's no pattern in this table. Okay, so it's not possible. Okay, so again, we can confirm that. So 3 times 2 is 6, right? Well, 5 times 2 is not 8. 3 plus 3 is 6. 3 plus 5 is 8. But 7 plus 3 is not 21. So these first and last ones are being multiplied by 3, but the middle two are adding 3. So it's just not consistent. Okay, it's not possible to write an equation. And 14, describe a real-world situation in which there is a relationship between two quantities. Make a table that includes at least 3 pairs of values. Then write an equation that models the relationship between the quantities. All right, well, how about the amount Stephen earned is equal to 30 times the number of hours worked. All right, so we're going to say hours worked. I'm going to call that H. And total earnings, I'm going to call that E. All right, so the equation is E equals 30 times the number of hours. Okay, well, if he works 3 hours, he's going to make $90. 3 times 30. If he works 4 hours, $120. 5 hours, $150. 6 hours, 180. Simple as that. Okay. And finally, 15. Georgia knows that in the relationship between two given variables, x and y, each value of y is found either by adding a given number to the corresponding value of x or multiplying it by a given number. She only knows a single pair of x and y. Can Georgia write an equation that models the relationship? So what we're basically saying is we only have this. We only have 3 and 6. Well, do you know whether it's adding 3 or multiplying by 2? If that's all you know? No, we can't tell. So she can't. So if we don't know whether to add it or multiply it, you can't write it. She can't write an equation. So basically, we need to have at least 2 values or 2 pairs of values. All right, so that's it for writing equations from tables. So we will conclude our discussion of Module 12 in our next sessions. And until then, I will see you soon.